Saxon Course 2, Lesson 103 is on powers of negative numbers, dividing terms, and square roots of monomials. So here we want to find the product of this amount. So first we need to figure out if this is going to be a positive or a negative number, because then I can just multiply the numbers like normal. Remember, if the number of negative factors is even, the product is positive. If the number of negative factors is odd, the product is negative. So let's count how many negative numbers we have. 1, 2, 3. Well, since there are 3 negative numbers, my answer is going to be a negative number. So now I can go ahead and just multiply these together. And if I multiply them together, 3 times 4 is equal to positive 12. Okay. Negative 5 times negative 2 is equal to a positive 10. And then I still have a negative 3. Okay. Multiply these two. 12 times 10 is equal to 120, positive. And I times that by a negative 3. So 120 times a negative 3 is equal to a negative 360. Okay. This next one we have negative 2 to the 4th power. So that means negative 2 times negative 2 times negative 2 times negative 2. Since there is an even number of negative factors, the product will be positive. Okay, so negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. Okay, on B, it's negative 2 to the 5th power, so that's going to be negative 2 times negative 2 times negative 2, 5 times. Okay, since there are 5 factors, that means my answer is going to be negative. So I can 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So my answer is negative 32. Alright, so when we divide terms, we can remove pairs of factors that equal 1. So here I have 12x cubed yz squared over 3x squared y. So if I was to write that out, it would look like something like this. 12 times x times x times x times y times z over 3 times x times x times y. So I can go ahead and cancel the factors that would equal 1. So that's going to be, I can cancel the same thing on top and bottom. So the x and the x cancel, these two x's, and then the y and the y will cancel. I can also reduce 12 and 3. 3 becomes a 1 and 12 becomes a 4. So after I take into account everything I've canceled, I end up with 4 times x. Okay, because I only have one x. I'm going to cross these off when I'm done. So 4x, and then I have 2 z's, so that's going to be z squared over, then on the bottom, I have a 1. All I have is a 1 left. So my answer is just 4xz squared. Okay, this one, we have 10a cubed bc squared over 8ab squared c. So again, if I wrote that out, it would look like this. 8 times a times a times a times b times c over 8 times a times b times b times c. So now I'm going to start to cancel. So these a's can cancel, these b's can cancel, and these c's can cancel. Then I can cancel the 10 and the 8. I think I can divide 10 and 8 both by 2. 10 divided by 2 is 5, and 8 divided by 2 is 4. So if I rewrite it, my answer, I end up with 5 times, I have 2 a's, so it's going to be a squared, and then I have 1 c, so c, over 4 times 5 times 2 is 8. So 4 times 5 is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 times 2 is 40. So my answer is 25. 25 I have 1b, and that's it. So when I reduce it, I end up with 5a squared c over 4b. Okay, so a monomial is a perfect square if its prime factorization can be separated into two identical groups of factors. So here I need to figure out which one is a perfect square. So I have 8x squared y to the 4th power. So I have to see if each of these terms can have a square root. Okay, a perfect square root. So the square root of 8 is not a perfect square root. So this one cannot be a monomial with a perfect square because the square root of 8 is not perfect. Let's look at the next one. So 4x squared y. Well, 4 is a perfect square, so that's good. X squared is a perfect square. That's good. But y is not a perfect square. So it cannot be b. So then the last one is c. We have 36x squared y to the 4th power. Well, 36 is a perfect square. Okay. X squared is a perfect square. And y to the 4th power is a perfect square. Because if I squared each of these, did the square root of each of these numbers, I'd end up with 6xy squared. So C is my perfect square. Okay, and so here, simplify this this number, 36x squared y to the 4th power. So there are two different methods we can do this. The first way is we can separate the factors of 36x squared y to the 4th power into two identical groups. So that's going to equal 36, we find the prime factorization, which would be 2 times 3 times 3. Then I'd have times x, and then times y times y times y times y. Okay, so then I can group them into two groups. So I'd end up with 2 times 3 times x times y times 2 times 3 times x times y. Okay, and then group on my terms. So that's going to be 6 times 6x y. Oops, forgot to add another y. 6xy squared times 6xy squared. So the square root of this number is equal to 6xy squared, because this number times itself is equal to the 36. The second way is a little bit faster, and we can just find the square root of 36 and